Hello viewers, welcome back to the Epic Science Show. What if I told you that the Earth is not spherical, but is actually a flat plane? We've all heard this one before, people claiming that we have been lied to all our lives, and that they know the truth about our home planet. The Earth is flat.
Despite hundreds of years of empirical evidence, some people are still not convinced that the Earth is indeed a sphere, and maybe some of our viewers are not convinced either. In this video, we will learn about how we know for a fact that the Earth is round.
At first, we had a few different ideas of what the shape of the Earth was. The initial ideology that we had from ancient civilizations, they believed we lived on a planar disk. I mean, it looks flat, right? This idea lasted until around 300 BC, when Greek polymaths and philosophers like Pythagoras, Plato, and Aristotle produced strong empirical evidence of the sphericity of the Earth. Part of the success and acceptance of the spherical Earth model was thanks to Eratosthenes, who famously calculated the circumference of the Earth using a stick in the ground around 240 BC.
He knew that in an Egyptian city called Syene, south of Alexandria, on the summer solstice at noon, no shadows are cast, meaning the sun is directly overhead. He wondered if the same effect existed in Alexandria, so he planted a stick vertically into the ground and watched it on the summer solstice. As it turns out, the stick did produce a shadow and found the shadow was cast at an angle of around 7.2 degrees. Since a shadow was cast in one place but not in another, the Earth must have some curvature. Using this measured angle and the approximate distance from Alexandria to Syene, he was able to calculate the circumference of the Earth to be 250,000 stadia, or 39,425 kilometers. This incredible measurement is within 1.5% of the true value for the circumference of the Earth, which is 40,008 kilometers.
Considering the apparatus used to get this measurement consisted of just a stick, talk about impressive.
But this happened so long ago. How is it credible? When I stand outside and look around, the Earth is clearly flat.
Yes, it's true. If you were to look down the road, or stand in the middle of an empty desert, the Earth would appear to be flat. However, this is just an illusion due to the properties of spheres and other convex surfaces. The closer you are to the surface, the flatter it appears, but as you move away from the surface, the more curvature you will be able to see. Consider a tiny spider sitting on top of one of the largest man-made spherical structures ever built, the Avicii Arena in Stockholm, Sweden. From the spider's perspective, it would appear to be on a flat surface, but us humans are large enough and far enough away from the arena to notice that it is indeed a sphere, though it may be difficult to convince the spider. Similar to the spiders standing on the Avicii Arena, us humans stand on the Earth. The average person can only see about 5 to 6 kilometers away from themselves. Because of the size and the scale of the Earth, its curvature is not noticeable from our perspective, much like how the spider can only see a flat surface. So how can we see the curvature, you ask? Well, thankfully today, we have the equipment and technology to see the Earth from many different perspectives.
Now, in order to get the full picture, we need to broaden our horizons, literally. For example, this website called heywhatsthat.com allows us to visualize our horizon in different places and from different heights. First, we'll input what our horizon looks like in the middle of a field at about 2 meters of elevation, which is about the height of a tall person. So as you can see, our horizon is described here by the red cloak, as you can see, is on a scale of about 5 to 10 kilometers. Some of the red patches that you can see, though, that are far away from our position are simply the elevation changes of distant objects that peak out just above our horizon. In comparison, this is what our horizon would look like on top of the CN Tower, 553 meters of elevation. Now our horizon extends closer to 50 to 100 kilometers. What we're seeing here is that the increasing altitude, we get a greater horizon. So simply, the further away from Earth we are, the more of it we can see.
Now that we know a little bit about horizons, just how far do we need to be in order to see the curvature of the Earth? In a paper by astronomer David K. Lynch, he explores just how far away one needs to be to see the curvature. Lynch concludes that under the right circumstances, the threshold for detecting curvature is approximately 11 kilometers away from the surface of the Earth.
This is approximately the altitude at which commercial airplanes fly. So next time you're going on vacation to Hawaii, make sure you look out the window to check for yourself to see that the Earth is indeed not flat. Thanks for watching.